Hi everyone, this is lesson 6.4 on side, 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 and side angle side similarity theorems. So we already learned about angle, angle similarity theorem, and there are two other shortcuts for proving that triangles are similar, which are these two. So the side, side, side one, kind of just like what the other ones for congruence were, but with similarity. If you know that three sides of one triangle are proportional to three sides of another without knowing the angles, then you know that the triangles are similar. So here it just shows that AB and RS are proportional to BC to ST to CA to TR. And then you know that they are similar triangles. So here it says, is either DEF or GHJ similar to triangle ABC? So we would check the proportions. So you could say, and they're kind of color-coded nicely here. So you could say 16 over 12, and then you would check to see if the other side ratios are the same. So that reduces to, they're both divisible by 4, so 4/3. And I'm actually going to color code a little bit here. So how about 8 over 6? That's 4/3. And if I do the green side, that is 12 over 9. I don't know why that stopped working. Oh, looks like my pen turned off. So 12 over 9 simplifies to divisible by 3, so 4/3. So this one is a yes. And then how about the other one? So let me get rid of this writing. So let's start with the blue side. 16 over 16 is 1. And then 8 over 8 is also 1. And then 12 over 10 is not equal to 1. So this would be no. So this is yes, this one's no. Not similar because not all of the ratios of the sides are the same. Determine which two of the three triangles are similar. Find the scale factor for the pair. Okay, so we would kind of do the same thing. So check the ratios. So we'll check, and what you want to do, because you don't always know that the triangles are like oriented the same way if they were similar. So you want to match up the smallest side length. So we'll start with the smallest side lengths of each of them. So we'll do 16 over 12 first, because those are the two smallest sides of these two. 16 over 12 is 4/3. And then if you do 20 over, the next shortest side length would be the 20 and the 16. So 20 over 16, if you divide by 4, you would get 5/4. So these two are not going to be similar. But the ABC might be similar to the other triangle on the right. So we'll check those ones. So again, I'm going to start with my smallest side. So we'll go 16 to 20. And that gives me 4/5. And then I'm going to check 20 to 25, because that's the next shortest side length. Gives me 4/5. And then the longest side is 24 to 30. Both divisible by 6 would give me 4/5. So triangle ABC is similar to triangle GHJ by a scale factor of 4/5. So that would be one of them. And then if you check these two, if these two are not similar, but these two are, then these two are not going to be similar, just by how similarity works. And then the next one is going to be side angle side. So this means if you have two sides that you know are proportional and the angle between them is congruent, it has to be the angle between them, not another angle, then you know that the triangles are similar. So here we would have ZX and MP. I'm doing like a similar thing, not congruent. And then a little squiggle to say that they're proportional. And then those two. So the sides and then the angle between them, X and M. So a few examples of that. It says find the value of the variable that makes the two triangles similar. So you could set up a proportion for this. So for here, you could do 27. You know that they are going to be similar, so you could do 27 to, so AB matches with DE, so 18. So 27, 18, and then that equals, you could do 15 to 2 times x plus 1. And I might simplify this before I get started, because 27 over 18 I can reduce to 3 over 2, because they're both divisible by 9. And then that's 15 over, and then this would be 2x plus 2. So then if I cross multiply, I get 3 times 2x plus 2, and I'll have to distribute there, equals 30. And then distribute the 3, so 6x plus 6, where you could divide by 3 by the 30. Subtract the 6, so 6x is 24, so x equals 4. All right. Excuse me. For the number 4, it says find the, and we did not end up using this one. You could have done 20 over 8x plus 1, but I would not have used like those two, because that would have caused me to have a quadratic equation, and I would have had to factor, and because I would have had like x squared when I cross multiplied. So just be careful about how you set up. You don't want to put x's on the opposite sides of each other in the proportion, because then they're going to multiply and make x squared. You don't want a quadratic formula if you don't need one. Quadratic equation. So here this says find the value that makes the two triangles similar. Okay, well, they're both 60 degrees here, and then we would set up the sides proportional. So you could say 3x plus 4 over, and then if they're both 60 degrees, then this is actually equilateral. So it doesn't matter if we do, well, I guess no, sorry, that's not technically true if it's 60 degrees. We don't know enough about that. But anyways, so if you know PR matches with TU or TV. So that's TV. So these two sides are proportional. So that's over 20. And then you got the other two sides, 30 over 24. All right, so I'm going to simplify this fraction. 30 over 24 would be divided by 6, so 5/4. And then cross multiply, so this would be 4x plus 4 times 4 would be 12x plus 16 equals 20 times 5 is 100. 12x equals 84. 84 divided by 12 is 7. Okay. And the challenge one says, if x equals 1, which triangles are similar and by what method? So if x was equal to 1, this would be, I'm not sure why this is necessarily challenged, but this would be 3 plus 5, which would be 8. And then you have the vertical angles, so vertical angles that are congruent. And then the smallest side length here is 14 and 8. So you've got 14 over 8, which is 7/4. And then check to see if 24 over 16 or 28 over 16 is that also 7/4. Divide both by 4 and you get 7/4. So yes. So yes, they are by side, angle, side, similarity. You could say that the two triangles are similar. And to write a triangle congruent statement, you would say triangle. I could say RQP is similar to triangle R and then ST. And the other one, you would just do kind of the same thing. So you just plug in 1, compare the two ratios. Actually, are these the same? Oh, this says if x is 9. Okay. Yeah, so you would do, if x was 9, then that would be 3 times 9 is 27, plus 5 is 32. So then actually these two sides would be the ones that are proportional. So the triangle here would be flipped. So this would be 14 over 16, which is 7/8. And this would also give you 7/8. So they are proportional, but you would say triangle RQP is similar to triangle R. Oh wait, this would be R. This would also be RST. Did we write it wrong earlier? I think we did. Because if this is 14, then that side is 8. Those are the two corresponding sides, technically, even though it doesn't look like 8. Okay, so a lesson in being careful that you're reading the numbers correctly and not just going by what it looks like. This should be RTS, not RST. My apologies. RTS. So, in summary, these are your 3 triangle similarity theorems that you can use for proving triangles are similar, the shortcuts for proving them similar, rather than showing that all 3 sides are congruent and all 3 angles are proportional.